Hi again. This is the graphic organizer that is going to be used for the next 6 days. We are going to fill this in together. I'm going to explain what I would like, but if you don't want to listen to me, which you probably don't, your textbook has all this information on pages 330 to 339, and there's a chart kind of like this already set up. So if you want to just copy that, that's great. For each of the 6 types, notice I have a 6th one. The book only says there's 5. But for each of the types of reactions, I'd like you to write the definition here. I'm not going to do that with you. I'm going to let you copy that on your own. The Google slide document that I posted or created has little text boxes. You can type it in if that's what you want to do. You're more than welcome to just draw your own chart and do it by hand. I don't care. But let's get started with the first type of reaction. Our book calls it the combination reaction. Most books that I've ever seen call it the synthesis reaction. The general format for the equation looks something like this, and it's a little bit strange. The box is a little tight, but I'll try and make it fit. Something R plus something S comes together and forms a single product. So remember, reactants are on the left, and those reactants form, produce, yield, make, generate the products. Okay, so the reactants are typically 2 elements, not always. They can be an element and a compound. They can be 2 compounds. But the key for this type of reaction is the signal when you look at an equation to tell what kind of reaction it is there's only one product, one single compound that's the product. So an example and of what you're going to actually see in the not too distant future is the combination of solid magnesium ribbon with oxygen gas that's in the air. Remember, oxygen's diatomic. That's a little tricky tidbit that you're going to have to watch out for, especially when doing the reaction equations. I'm going to put the arrow here and the product down below. Remember that magnesium is a metal, and when it forms an ion, it forms a +2 ion. You probably also remember that oxygen is a -2 ion. So when magnesium and oxygen come together, they go together 1 to 1, and they also form a solid. You don't know that yet. You don't need to know it, but I'm just writing it down there. So on the beginning, we've got 1 magnesium. At the end, we have 1 magnesium. Beginning, we have 2 oxygens. At the end, we only have 1. So this reaction is going to require coefficients. Remember, we don't change subscripts willy-nilly. They have to go based on the charges. So in order to get 2 oxygens at the end, because I have 2 at the beginning, I'm going to put a 2 coefficient at the front. So that took care of my oxygen problem. Remember, this is now MgO, MgO, right? 2 oxygens, 1 oxygen molecule. And so now I also need a coefficient in front of the magnesium ribbon. The 1 is understood in front of oxygen. You don't have to write that, but we have to take care of balancing it, and we have to make sure our compounds are properly put together. So this is where we incorporate all the stuff we've been learning so far. All right, so that's a combination reaction. Remember to fill this in, and I'll come back and show you how to balance equations in the next video.